A very good morning everyone. In this module we will going to discuss about the modern trends in periodic table. Trends in periodic table like the atomic radius, electron affinity, electronegativity, ionization energy. This in brief we have discussed in the last class, but in this module we will going to discuss it from your given reference book from school, that is Ratna Sagal Living Science. So let's start to this class. So first point, you can see electronic configuration of elements. How electronic configuration decides the chemical properties of any element, that will come to know. Okay. So the properties of elements depend on their electronic configuration. We know each element having different atomic number in the periodic table. So what is the atomic number? The number of electrons and protons present in an atom. The number of electrons is always equal to the number of protons. So we can distribute the electrons in different orbits. So depending on this type of distribution, we can organize the elements in the periodic table in different groups and in different periods. So you can see here that the properties of elements depend on their electronic configuration. Electronic configuration of any element depends on its how many electrons present in any atom. Like suppose in case of sodium there is 11 atomic number. It has 11 atomic number. So how will distribute the electrons? 2, 8, 1. In the outermost shell it has 1 electron. In case of potassium, its atomic number is 19. So how will distribute the electrons? 2, 8, 8, 1. So in the outermost shell it also has 1 electron. So all of them are arranged in the group 1. How? Because their outermost shell contain 1 electron. So all the elements which are having 1 electron in the outermost shell, they will be arranged in the group 1. In case of period 1, if you consider period 1, you can see each only hydrogen is present and one hydrogen has atomic number 1, so it has only one cell. In case of period 2, if you will see that there will be two orbits. Like lithium 2, 1, 2 orbit K and L. You will go for boron 2, 3. So likewise, all are having two orbits in their electronic configuration. They are togetherly placed in the single group, that is group 2, period 2. So if you move down a group, what you'll see on moving down a group from top to bottom, from up to down or top to bottom, if you'll see in a group, if you'll have a textbook, you will open the periodic table and see. When you'll come down the group, you will see there will be the successive increase of number of electron orbit one by one. 1 by 1 means in case of sodium it is 2, 8, 1. When you will go for the potassium, there is 2, 8, 8, 1. So 1 orbit is going to increase when you will come down of the group. Thus in group 1 elements, lithium has 2 orbits, sodium has 3 orbits, potassium has 4 orbits, and so on. The elements in the same, so the valence electron, another thing we will get similar in the groups. We'll see that all elements present in a single group, present in a same group, having the equal valence electron in their valence shell. Valence shell means outermost shell is called valence shell. The chemical properties of elements depend on the valence shell, valence electron. You will see that valence electron in the consecutive elements in a group are repeated after a certain interval of atomic number. Suppose in case of consider sodium and potassium, there is a certain interval of atomic number, that is 8, but their outermost shell has the 1 electron, so it is repeated. So the properties of the elements in a group repeat periodically over the regular sequence of repetition of atomic numbers. The number of valence electrons determines valency of an element. In some elements, we will see that outermost shell contain 1 electron, 2 electron. We will tell that its valency is 1, its valency is 2. If its outermost shell contain more than 2 valence electron, then what we will do? We will add 10 with the valence electron. Then we will determine the group number. Suppose aluminium has 3 electrons in the outermost shell. To determine the group number of aluminium, we have to add 10 with it and we will determine its group number. So the outermost shell is called valence shell. Valency of representative elements is either equal to the number of valence electrons or 8 minus number of valence electrons. Suppose you can consider chlorine. Chlorine contain in the outermost shell 7 electrons. So we cannot say it will lose 7 electron because it will cause disability to the stability of the atom. Suppose you will see that 7 electrons will come out from chlorine, then how many electron will be there? 10 electron, 17 protons. There will be very discrepancy between their number, so that's why there will be instability in their configuration. So that is not possible, so we have to subtract 7 from 8 to identify the valency of an element. And always these elements have the tendency to reach its octet. That outermost shell should contain 8 electrons. Anyhow, if we want to release the electron, if we want to gain the electrons, but it has the tendency to gain the electronic configuration of the nearest noble gas. This rule is applicable to transition elements which exhibit variable valency. So this rule will not be applicable to the transition elements which exhibit variable valency. Since all the group 1 elements have one valence electron, so all the group 1 elements exhibit similarity in chemical properties. Similarly, if you will consider group 2, they will also have the similar properties. The elements of the same group exhibit same valency in their compounds. Thus, the group 1 elements exhibit valency of 1 in their compounds. So hydrides, if any element will combine with the hydrogen, it will form hydrides. So hydrogen has how many valency? 1. Lithium has how many valency? 1. So it will share the electron with each other and it will form lithium hydride. So LiH, KH, potassium hydride, sodium hydride, all are having same type of formulas, you can see. In case of oxide also, the group 1 elements having the 1 valency, when they will exchange their valency with the oxygen, always their formula will be, suppose X is the element, so X2O, because O has the valency 2 and X has the valency 1. So lithium oxide Li2O, potassium oxide K2O, sodium oxide Na2O, calcium oxide Ca2O, like this way. Not calcium oxide in different group, cesium oxide Cs2O. In case of hydroxides, OH always having the 1 valency minus 1. So when it will share with the, when the valence will be exchanged between the group 1 metals with the OH, then also it will form LiOH, lithium hydroxide, potassium hydroxide, sodium hydroxide, like this. So the group 2 elements have the same outermost electronic configuration, that is 2, and they exhibit valency of 2 in their compounds, like in case of hydrides, that is beryllium hydride BeH2, magnesium hydride MgH2, calcium hydride CaH2, strontium hydride SrH2, beryllium hydride BaH2. Oxides are beryllium oxide. Beryllium has how many valency in the outermost shell? 2, because they are group 2 elements, their valency is also 2. So beryllium oxide BeO, magnesium oxide MgO, calcium oxide CaO, strontium oxide SrO, like this. In case of hydroxides, hydroxide having 1 valency, so it will form BeOH whole twice, MgOH whole twice. calcium hydroxide CaOH whole twice, like this. So the number of valence electron in the elements of group 13 and 14 is 3 and 4 because we have add 10 with it to determine its group number. Remember that they in given question, very frequent questions are coming to they will give the atomic number, you have to identify their group number and period number. That time we need to remember that whenever the valence electron will be exceeds the more than 2 electron in the outermost cell, so then we have to add 10 with the outermost cell electrons. For example, the valency of aluminium is 3 and that of silicon is 4. So how we have got? We have add 10 to the 4 outermost cell electron and we have get the group number is 14 for silicon. Now along a period, if you will see the electronic configuration, you will see there will be same number of orbits in all the elements present in the single period. So what you will see in the outermost cell, one electron is increasing. If you will go for the one by one consecutive elements, you will see one electron is added in the outermost cell. Initially you will see it will be increased up to 8, then again it will decrease from 8 to 1, except in the first period where the number of valence electron increases from 1 to 2 because helium has 2 electron. The first element in every period has only one valence electron. If we go for the each period, you can see that each period first element having the one valence electron in the outermost cell, and the last element in every period has 8 valence electron in their outermost cell. So they are considered as a noble gas. Their group number is 0 or 18. Except in the first period where the last element is helium, which has only 2 electron in the outermost cell. On moving from left to right, we will see that the one electron are added on the same orbit. This is in the second period, the electrons are added to the second orbit. If we'll, period T, if we'll see that on the third orbit, one electron is going to add. This is illustrated in table 5.8. You can see that lithium, beryllium, carbon, nitrogen, oxygen, phosphorus, neon. So they all are in group 2. So how they will form different compounds with hydride, with chloride, nature of the chloride, everything is given. Next, in the third period you can see sodium 281, magnesium 282, aluminium 283. So one electron is increasing the M cell. And how they are forming, and chlorine has probability to gain 1 electron, it can lose 7 electron. So these are the probabilities. So that's why it has written many valencies of chlorine, but it would have only one valency in the outermost cell. We will only remember with the chlorine if it will react. So chlorous oxide it will form, that is Cl2O. The elements in a period have consecutive atomic numbers. That means suppose sodium has 11 atomic number, magnesium has 12, then 13 aluminium. So it is consecutive atomic numbers of electrons by 1 every time. The number of protons in the nucleus also increases. Along with the electron, the number of protons is also increasing when we will move from the along the period, not in the group. When we are moving along the period from left to right, we will see that proton number is also increases. That's why its atomic radius decreases when we go from left to right of a period, because there will be more attraction between protons and electrons. So proton number is also increases by 1 every time, and also this leads to consecutive atomic numbers. As one moves from left to right in each short period, that is period 2 and 3, the valency of element increases from 1 to 4 and then decreases to 0 in the last elements of the period. So 0 means neon having 8 electron in the outermost cell. So 8 minus 8 will come 0. This change in valency in a period leads to change in the nature of compound. So the change in the valency will cause the change in the nature of compounds. The trends in the properties of compounds of second and third period are given table 5.9 and 5.10 respectively. Which of the following belongs to a same period and same group? Elements are given A, B, C. Okay. Element A having atomic number 2, B having atomic number 10, C having atomic number 5. So A having 2 electron in the outermost cell. That means it is A, B, C. B configuration is 2 comma 8, C configuration is 2 comma 3. So B and C having the same number of orbits. So they are located in the same period, that is period 2. The electronic configuration of B indicates that it is neon because its outermost cell is already fulfilled. So B is a noble gas and the electronic configuration of A shows that it is helium. So valence cell of K is completely filled. So the both A and B is placed in the same group, that is group 18 of periodic table. Using periodic table, predict the formula of the compounds which are likely to be formed by the combination of the following pairs of elements: aluminium and sulfur, boron, silicon, and chlorine. So aluminium belongs to group 13, and group 13 having the valency 3. Sulfur belongs to group 16, and the group 16 elements having valency 2. Sulfur having the valency 2. Hence, the formula of the aluminium sulfide should be L2S3. Silicon belongs to group 14 and chlorine belongs to group 17. So, group 14 means its valency is 4. Chlorine belongs to 17 means its outermost cell contains 7 electrons. But it has valency 1. So, SiCl4 will be the formula. Consider the elements sodium, cesium, boron, silicon, aluminium, calcium, strontium, carbon, and fluorine. Which elements belong to the same group? Sodium having outermost cell 1, cesium we know outermost cell contain 1, calcium don't have. So sodium, cesium, same group. Boron having 5, so 2 comma 3. Aluminium, boron belongs to the same group. Next, silicon having outermost cell 4 electrons, calcium having 2 electrons, strontium have calcium and strontium are in the same group. Carbon having 4 electron in the outermost cell, silicon also having the 4 electron in the outermost cell. So carbon and silicon also belongs to the same group. So fluorine combination is not given. Now same period 281, 281, 283, 2882, no, not calcium. So sodium, aluminium are belongs to the same group, same period. Given example, they have given totally the same. Sodium and aluminium belongs to the same group, same period. Rest of the totally the group totally the period 3 is given here, but only given elements if you'll consider, only will got sodium and aluminium and silicon also. 2 comma 8 comma 1, 2 comma boron is 2 5, 2 comma 3. So sodium, aluminium, silicon in the same period. Okay. Boron is 2 comma 3, fluorine is 2 comma 7, carbon is 2 comma 4. So boron, carbon, fluorine all are in the same period. What are left? Cesium, so I'm writing boron, carbon, fluorine in the same period, sodium, aluminium, silicon in the same period. How do you calculate the valency of an element from electronic configuration? Outermost cell content, how many electrons, that will be its valency, or you will subtract from it the valence electron. What is the valency of magnesium with atomic number 2 2? Sulfur having 286, that means 2 atomic 2 valency. Valency of first 20 elements you will calculate. How does the valency vary in a period on going from left to right? So if you will consider the group 2, you will see 2 comma 1 2 comma 2, so valency will be increased by 1. How does the valency vary on going down a group? Valency will not going to change, it will remain same. So it initially increases 1 to 4, then it will decrease. So these are the exercise question you will solve. Now atomic properties. The physical characteristic of the atom of an element are called atomic properties. The physical properties such as melting point, boiling point, atomic radius, ionization energy, electron affinity, electronegativity, electropositivity, valency density, etc. are atomic properties. So physical properties of the elements depend on the following factors. So periodic trends in atomic properties. That was discussed in the last class in brief, but today we will discuss from your book. The properties of elements exhibit a regular variation in the group and periods of the periodic table. The various atomic properties of elements which change on moving down in a group across the periodic table are described below. A thorough knowledge of the trends in the properties of elements not only helps to understand the properties of elements but also to predict the properties of yet to be discovered elements. It is impossible to study separately 117 elements, but it is rather easier to study the trends in their properties of elements. So, what is the atomic radius or atomic size? In some books, you will get atomic radius, in some books, you will get atomic size. The distance between nucleus and the last orbit, that is outermost cell, is called atomic radius. The distance from the center of the nucleus to the outermost cell of electrons in an atom is called atomic radius. Atomic radii of diatomic molecules are obtained from bond lengths of diatomic molecules. So in case of diatomic molecules, if it is hydrogen H2, there will be the bond length between the hydrogen and hydrogen atom. The bond length between hydrogen atom and hydrogen atom will gives us the atomic radius of diatomic molecules. The direct measurement of atomic radius does not provide an accurate value since the electrons do not move around the nucleus at a fixed distance from the nucleus. For example, in a solid lithium, atoms are spaced at a distance 268 picometer, yielding an atomic radius of 130 picometer from lithium. So, the atomic radius we are getting different value. So, bond length is 268 picometer. Atomic radius should be MO is equal to ON. So, half. So, that's why it is coming 134 picometer. The atomic radius of the elements group and group 1, 2 and 38 are presented in table 5.11. So we do not remember the atomic radius. We should only remember the how it is increasing or decreasing along the period. Either it is decreasing or increasing if it will come down of a group. So you can see if we'll go from left to right in a period, you can see that the atomic radius will be decreases, then again it will increase when it will come to the noble gas. So why it is decreasing the atomic radius? Because along the period, as the atomic number is increasing consecutively, That's why the number of electrons are increasing. Also, the number of proton is also increasing. That's why the attraction between electron and proton is high. That's why their radius and size will be smaller. So variation of atomic radius in a group. So atomic radius of atomic radii means the plural of elements increase with the increase in atomic number. So as in case of sodium and potassium we will consider, or lithium, sodium, potassium, three elements we will consider in group 1. We will see in the outermost cell all of them having the one electron, but one cell increasing when we will moving down the group. So that means there will be more size increasing. That's why atomic size is increasing when we will move top to bottom of a group. So that's why you can see hydrogen 37, it is increasing when it will come down the group. But if you see the period, it will first decreasing. Then in case of neon, when the octet is fulfilled, then it will be increased. So on moving down a group, a new cell of electron is added at each succeeding element. What I have told now. Hence, the electrons in the valence shell of each succeeding element further and further away from the nucleus. So, one orbit is added, and the distance between the last orbit and the nucleus is increasing. Hence, the electrons in the valence shell of each succeeding element lie further and further away from the nucleus. Consequently, the attraction of the nucleus for the electron decreases, and as a result the atomic radius increases with increase in atomic number, but the nuclear charge of elements also increases. Nuclear charge means number of protons increases. That's why the charge in the nucleus is also increasing, positive charge, but the nuclear charge of elements also increases. What it will produce? This produce an attractive force between the electrons and protons, and it will reduce the atomic radius. The increase in the atomic radius due to the addition of a new cell is so large that it outweighs the contractive effect of the increased nuclear charge. In case of group also it is increasing, the nuclear charge is increasing, but the orbit number is also increasing along the group. That's why the attraction between electrons or photons are not prominent. But in case of period, as there is no increasing of the number of orbits, that's why their nuclear charge is increasing and their attraction is prominent. That's why atomic radius is decreasing along the period. As a result, the atomic radius increases on moving down a group from top to bottom. Now, variation of atomic radius in a period. The atomic radius of element decreases with increase in the number of protons on moving from left to right in a period, or number of electron is also increasing, number of proton is also increasing. The atomic radii of second period elements are given here, you can see, and if you see the nuclear charge of a period group, period 2, you'll see that the charge is increasing. So on moving left to right of a period, the nuclear charge increases consecutively in each succeeding element, while the added electrons enters the same cell. Not the any new cell is added. In the same cell, the one electron is added. As a result, the electrons of all the cells are strongly pulled towards the nucleus. Hence, there is a steady attraction between the electrons and protons, and there will be the contraction of the atomic radius from, if we will move along the period from left to right in a period. Thus, in any period, if you will see the alkali metal atoms such as lithium, sodium, potassium has the highest atomic radius, while the halogen atom has the smallest atomic radius like chlorine, fluorine, etc. But atomic radius suddenly increases when it will come to the noble gas, because their interelectronic repulsion within a cell. The trend in atomic radius in groups and periods of periodic table is given in figure 5.3. You can see it will come down the group, the atomic radius decreases, atomic radius increases, and in case of from left to right, if you will come in a period, move in a period, you will see it will be decrease. So francium has the highest atomic radius and hydrogen has the smallest atomic radius. So atomic radius of the elements of the second period are given below. Arrange them in descending order of their atomic radius. So first it will come lithium, then it will come beryllium, then it will come boron, then it will come carbon, then nitrogen, then oxygen. Are the elements arranged in the pattern of period in the periodic table? No. Which elements have the largest and smallest atom? So largest one is lithium and smallest one is oxygen. Noble gas is not given here. That's why I have not told. So noble gas has the highest atomic radius, and the halogen one has the lowest atomic radius. So group 1 elements and atomic radius as given. Which have the smallest and largest atom? Smallest one is the smallest and the largest. So if we'll move down the group, the atomic radius will increase. So that means lithium has the smallest atomic radius and the last one has the highest atomic radius. So here will be lithium less than sodium, less than potassium, less than rubidium and cesium. How does the atomic size vary as you go down a group? It will increases if you will go down from top to bottom in a group. Did you know the enthusiasm to classify the elements on the basis of periodicity has been tremendous? This had led to the development of 15 different categories of periodic table. Till date, there are more than 700 forms of periodic charts of the elements and about 1 million numbers of internet citations. An expanded version of modern periodic table exists in which lanthanoids, actinoids are accommodated in the main body of the periodic table. If you see in the Wikipedia, you can find it out. Although most of these periodic tables are based on periodicity to predict the properties of elements, only 5 periodic tables have been developed for finding exclusively the detailed electronic configuration of the elements. Chemists have come up with the poems to describe the groups and periods. There are some Indian works too in the field of development of periodic table. Now, electropositive or metallic character. The tendency of an element to lose electron from positive ions is called electropositive character. So the tendency of losing electrons. So sodium when lose electron, it will form electropositive ion. So it is called electropositive character. Metal exhibits such tendency, that's why it is also called metallic character. Hence, metals are electropositive in nature. Metals tend to form bonds by losing electrons. So, the metals are characterized by ductility, malleability, and electric conductivity. The loss of electrons by a metal leading to the formation of cation. On the other hand, the nonmetals have the tendency to gain electrons and forming anions. So, the tendency of gaining electron is called electronegative character or non-metallic character. So the trends in the electropositive and electronegative character of elements are useful to predict the nature of the oxides. In case of metals, it will always form basic oxide. In case of non-metals, it will always form acidic oxide. On moving down a group, the metallic character of the elements increases because there is the increase in atomic radius and they have the higher tendency to lose electron from the outermost shell when you move down the group. As there is the more distance between the nucleus in the outermost shell, the outermost electron is loosely bound in the in the element. So that's why it can lose very easily. The force of attraction between the nucleus and electron decreases and less energy is required to lose electrons. The order of increasing metallic character in elements of group 1, 2 and 14 is given below. So you can see lithium to francium it is increasing, group 2 beryllium to rubidium it is increasing radium, and in group 14 carbon to germanium, strontium, lead it is also increases, because in this group 14 it starts with the non-metals and lead is the not highly reactive metal but it is a metal. So in group 14 carbon is a non-metal, silicon and germanium are semi-metals or metalloids. Tin and lead are metals, hence their metallic character increases, non-metallic character decreases when we move down a group. The non-metallic character decreases along the group. For example, in group 15 it decreases from nitrogen to bismuth. Now if you see the period, on moving from left to right, atomic radius is decreasing. That's why metallic character also will decrease, but non-metallic character will be increased. As we find, sodium at the extreme left is a metal and argon is the extreme right is a non-metal. The above trend is also true in the elements of other periods. The trend in the metallic character in groups and periods of periodic table is given in figure 5.4. The non-metallic character increases across a period from left to right, since the tendency to gain electron is also increases across a period from left to right. For example, in period 3, it increases from sodium to argon. From the above descriptions, we find that the elements with the strongest metallic character are found near the bottom left-hand corner of the periodic table, and the elements with strongest non-metallic character are found near the top right-hand corner of the periodic table. Relation between metallic character and reactivity. The reactivity of metals increases with increase in metallic or electropositive character. On the other hand, the reactivity of nonmetals increases with increase in electronegative character. Thus, the greater the electropositive or electronegative character of an element, the greater its reactivity. The trend in reactivity of elements of group 1 and 17 is shown below. When the atomic radius number increases, element is showing here metallic or electropositive character increases and reactivity also increases when you will come down the group. The metallic character increases, but if we will see from down to up, it will be electronegative character will increase and reactivity is also increases if depending on electronegativity. The distribution of metals, non-metals, semi-metals in the periodic table is shown in table 5.14. So arrange the following elements in the order of increasing metallic character if you will see. So magnesium in different one. So if you see in a period, all are belongs to the same period. So sodium greater than magnesium, greater than beryllium, greater than silicon is a same metalloid, then phosphorus is a non-metal. An element of group 14 as the atomic number 14, examine if this element will have metallic properties or not. So it has the tendency to lose 4 electron, it has the tendency to add 4 electron. So it is lying in the middle of the third period, does not have any tendency to lose electron, hence it does not exhibit metallic properties. Examine third period elements and classify them as metals, non-metals. That you can do. So practice this type of question. In the next class, we will going to study other trends in the periodic table. Okay. Thank you, class.